So we are going to discuss Monte Carlo methods today. And what are Monte Carlo methods? Monte Carlo methods or Monte Carlo experiments are a broad class of computational algorithms that rely on repeated random sampling to obtain numerical results. The underlying concept is to use randomness to solve problems that might be deterministic in principle. Monte Carlo methods are mainly used in three problem classes: optimization, numerical integration, and generating draws from a probability distribution. Monte Carlo methods are very important in computational physics, physical chemistry, and related applied fields, and have diverse applications from complicated quantum chromodynamics calculations to designing heat shields and aerodynamic forms, as well as in modeling radiation transport for radiation dosimetry calculations. In statistical physics, Monte Carlo molecular modeling is an alternative to computational molecular dynamics. And Monte Carlo methods are used to compute statistical field theories of simple particle and polymer systems. Quantum Monte Carlo methods solve the many-body problem for quantum systems. In radiation materials science, the binary collision approximation for simulating ion implantation is usually based on a Monte Carlo approach for selecting the next colliding atom, to select the next colliding atom. In experimental particle physics, Monte Carlo methods are used for designing detectors, understanding their behavior, and comparing experimental data to theory. In astrophysics, they are used in such diverse manners as to model both galaxy evolution and microwave radiation transmission through a rough planetary surface. Monte Carlo methods are also used in the ensemble models that form the basis of modern weather forecasting. These are some applications of Monte Carlo methods, and today we are going to discuss how to estimate the value of pi by using a Monte Carlo method. That is estimation of the value of pi. The idea is to simulate random xy points in a two-dimensional plane with domain as a square of side 2 units. So I take a square, I have taken a square with sides 2 units. Let me enlarge it a little bit. So I have taken a square, the length of whose side is 2 units. Then imagine a circle inside the same domain with same diameter and inscribed into the square. So inside this square we have inscribed a circle. So the diameter of the circle is 2 units. Therefore, the radius of the circle is 1 unit. We then calculate the ratio of number of points. Ratio of number of points that lie outside the circle and total number of generated points as shown in figure. We have a square, the length of whose one side is 2 units, and then we inscribe a circle with a diameter of 2 units inside the square. We generate a number of random points inside this square. Discuss about random number. We generate a number of random points inside this square. Then what do? We then calculate the ratio of number of points that lie inside the circle and the total number of generated points as shown in the figure. Sigi square sigi manungda generate toribo point mayamdo gi manungda circle sigi manungda na kayam tai adudagi sigi total square sigi manungda na kayam tai haibado ani dugi ratio lobuneba. Ratio loraga pi gi value estimate tawodoriba. Kamaina tawodoriba? Okay, let us see. We know that area of the square is 4 units. Because the length of a side is 2, therefore the area of the square is 2 squared, and that is 4 units. while that of the circle is, what is the diameter of the circle? The diameter of the circle is 2 units. Therefore, the radius of the circle is 1 unit. Therefore, area of the circle is pi r squared, and that is pi into 1 squared, and that is pi square units. There you go. So this should be pi square units. Now we generate a very large number of random points inside this square. So inside the square, for a very large number of generated random points, area of the circle, area of this circle divided by area of the square, this area of the square, this should be equal to the number of points generated inside the circle, the number of points that lie inside the circle, divided by the total number of points generated. That is the total number of points that lie inside the whole square. So area of the circle, as we have seen here, area of the circle is pi. Area of the square, as we have seen here, area of the square is 4. So, area of the square, 4 is in a right hand side. So this division becomes multiplication. So area of the circle is in a pi. So we have pi equals 4 times the number of points generated inside the circle divided by the total number of points generated inside the square. So this is how we estimate the value of pi. I repeat, in a length 2 unit over square am laure, square is the diameter 2 units over circle am inscribe taure. Then I generate a number of random points inside this square, and out of those random points, some would lie inside the circle, some would lie outside the circle. So we collect the number of points that lie inside the circle, then we divide it by the total number of random points that were generated inside the square. This ratio should give you pi by 4. Pi by 4. So when you multiply that ratio by 4, you get an estimate of the value of pi. There we go. And what is the beauty of this algorithm? The beauty of this algorithm is that we do not need any graphics or simulation to display the generated points. We simply generate random xy pairs and then check if x square plus y square is less than or equal to 1. If yes, we increment the number of points that appear inside the circle. So I x, y, z axis, x, y axis. So let me insert the x, y axis. So this is the origin. This is the origin, and this is the x axis. And again, so this is to the. Let me take this as red. Okay, and then let me insert another line. So from this, we insert the y-axis. So this is the y-axis. So this is the x-axis. This is the y-axis. This is the origin O. This is the origin O. And what is the radius of this circle? The radius of this circle is 1 unit. Then take any point. Take any point. Twice the level point. I'm at the point to coordinates to na x, y. Then x square plus y square equal to 1. I have a points. My amduri locus to the x square plus y square equal to 1. I have a point. My amduri locus to the. It is a square. Sorry, it is a circle of radius 1 and center at the origin. So x square plus y square equal to 1 represents points on the circle. On this circle, see circles the level point mein am x square plus y square equal to 1 represent less than 1 x square plus y square less than 1 x square plus y square less than 1 represents all those points which lie in the interior of this circle. Circle sige manung dalay point mayam duna neba x square plus y square is less than 1. 1 is the square of the radius, and since the radius is 1, 1 square is 1. So x square plus y square is less than or equal to 1. Meaning it consists of all those points on the circle and all those points which lie inside the circle. So if I generate a random number and call it x, and then if I generate another random number and call it y, adu orgadi hojiki random number aniduna x coordinate amasung y coordinate over point amasida namo namani ko, and then for that point we calculate x square plus y square, and if that value is less than or equal to 1, it means that point lies inside the circle. If the point does not satisfy this condition, that means the point lies outside the circle. So let us look at the algorithm. Algorithms, how to estimate the value of pi, using Monte Carlo method, using random numbers. Algorithm number 1, the initialize circle points, square points, and interval to 0. Circle points ini kaino count about this kaino first variable ahum hana declare the first we will define 3 variables. What are those variables? Circle points how variables na, this will count the number of points which lie inside the circle. Square points how variables na, it will count the number of points that lie inside the square. And interval how variables na, IC points random numbers pair of random numbers generate interval. Initially at the very beginning of the program, set the number of points in the circle to 0, number of points in the square to 0, and set the interval to 0. Then generate a random number and give it the and assign it to the variable x. Generate a random number and assign it to the variable x. Next, generate another random number and assign it to the variable y. X ko y da aduna random number ani generate tore, ahan random number generate tawduna x kore, ani super random number generate tawduna y kore. Using these values of x and y, I can put the point in the xy plot. I sigi Cartesian plane jida aina hojiki x ki value duga y ki value duga lauraga adugi point to sigi plane jida karai da laigida and point to get out number yarni ka. Suppose x is 0.5 and y is 0.3, then along the x-axis I will move 0.5 length along the x-axis, and along the y-axis I will move 0.3. So the point would lie somewhere here. So I aduna random number generate tore, we assign it to x. Random number second random number generate tore, we assign it to y. Then we calculate d equal to x square plus y square. X square plus y square is the square of the distance. It is the square of the distance of the point from the origin. And if this d is less than or equal to 1, the point lies inside the circle. And if this d is less than or equal to 1, what is d? D is actually x square plus y square. Aduga asing bagidi square root low case the square root low. So d is actually x square plus y square, and that value of d, if it is less than or equal to 1, it means the point lies inside the circle. Therefore, we increase the number of points in the circle by 1 unit. The circle points, I say we increase it by 1 unit. Sigi points in a circle sigi manung the taradi 1 unit increase tore. All those points which lie inside the circle automatically lies inside the square. Circles is square. Inscribe the whatever points lies inside the circle, automatically it lies inside the square. Aduna square dazu point increase toro. And increment interval. Then sigi interval 0 thamamadu increment toro. Then check toro. What is this? Check if interval is equal to number of iterations. Point generate point kayam generate initially we said that we should generate a large number of points generate that point kayam generate that is given by the number of iterations. So for example, we want to generate 1,000 points, then this number of iterations would be 1,000. Interval na I point kaya generate So initially interval was 0. So after one increment, step number 7, the interval becomes 1. 0 plus 1, 1 tare. So point number generate tawre. And if interval is less than the number of iteration, then repeat from step 2. Iteration. Then what do? We go back to step 2 and then we generate a random number and assign it to x again, and then we generate another random number and assign it to y, and then we perform the check whether the point lies inside the circle or not. If the point lies inside the circle, we increment the circle point by 1. If the point lies outside the circle, circle points increment tawdre, but the square point increment tawani ko. For every xy we take, the square points will always be incremented. Why? Because the random number that we generate always lies between 0 and 1. And generate or random numbers, it always lies between, say, -1 and 1. 0 and 1. Okay. Let us look at the program. Sigi Python program. Okay. So let me show you the Python program here. Sigi Python program say the random hyper module sigi manungda random hyper method. This is a method or also a function. Seasonal kari generate this random method, it generates a random number which lies between 0 and 1. So the value of x will always lie between 0 and 1. The value of y will always lie between 0 and 1. Let us come back to the picture here. We come back to this picture here. Here, if the value of x lie between 0 and 1 and the value of y lies between 0 and 1, it simply means the first quadrant. All the points lie inside the first quadrant. Adana sigi pictures the look at this picture. It has 4 quadrants: first quadrant, second quadrant, third quadrant, fourth quadrant. So the the square and the circle, both of them possess the symmetry. And what is that symmetry? Sigi kari symmetry no hargadi, the area of the sector of the circle. Sigi circle sigi sector. The area of the sector which lie in the first quadrant is only 1/4 the area of the circle. First quadrant the circle area 1/4 lay. In a similar way, in my first quadrant, square area is square total area is 1/4 lay. 1/4 amalay. So in the first quadrant, the area of the sector of the circle is 1/4 the total area of the circle. Similarly, the area of this smaller square with units with side of one unit length, this area is also 1/4 the total area. Aduna area of the circle divided by area of the squares. Area of the complete circle divided by area of the squares. We can restrict it to the first quadrant. First quadrant ki portion that is area of this sector of the circle which lie in the first quadrant divided by area of the smaller square which lie in the first quadrant. Because this area is 1/4 the area of the circle, and square area is 1/4 times the area of the square. And so when we take the ratio of this to 1/4, 1/4, we get area of the circle divided by area of the square. I see quadrant study I can study only the first quadrant. I can study only the first quadrant, and then I can apply this rule: x square plus y square is less than or equal to 1. So we are going to study only the first quadrant, and then we find the number of points that lie inside this circular sector. Circle is part ama sector the study. Then we also count the number of points that lie inside this smaller square, and then we take the ratio of these two. The ratio of these two should give us pi by 4. There we go. Okay, let us come back to our Python program. So although I quick first, this is a program to estimate the value of pi by a single measurement. So first, I random module is important. Random module is important. Why do we import this module? Because random module random functions use we want to use the random method which is present in the random module. And what does this random method produce? Output when we call this random method, what will be the output that it gives? It gives a random number which lies between 0 and 1. I repeat, this random method, it gives a random number which lies between 0 and 1. Okay. So first we import the random module, then in the second line we write n equal to integer input, enter the number of iterations. Iteration character upami haibdo akoina sida input the kaurani, then this input will return it as a string, then this integers in amuk sigi functions in amuk, it will convert it into an integer, and that number will be stored in the variable capital N. Then we initialize m to 0. What is m? M counts the number of points which lie inside the circular sector. I repeat, first quadrant we will see first quadrantal derivative 4 times. I can confine myself only to the first quadrant. In the first quadrant, confined to that is because of the limitation of my random module limitation error, because my random module it generates a random number which lies between 0 and 1. So whatever random number it generates for x, it lies only along this part from 0 to 1. And random numbers along y also it generates between 0 and 1. So whatever random number it generates, it lie only in this sector, only in this first quadrant. Aduna first quadrant sigi sector ziga sigi square ziga and sigi ratio lower gadum yaiko, because the ratio of these two parts is simply equal to the ratio of the circle to the ratio of the area of the circle to the ratio to the area of the square. So we are concentrating mainly on the first quadrant. So m is the number of points which lie inside the circle. So initially the number of points which lie inside the circle in the first quadrant is 0. Initialize the so this is step number 1, initialization of the number of points, and number of iterations we have kept it as n, capital N. Next, for I in range n. So steps, you repeat this step for n number of times. For n number of times, repeat to have any steps random dot random. Random module random method to call toro. This will generate a random number lying between 0 and 1, and then that number will be assigned to x. Similarly, a random number lying between 0 to 1 is another random number 0 to lying between 0 and 1 is again generated, and that number is assigned to y. So x ki value fange, y ki value fange. These are random numbers lying between 0 and 1. Then we calculate d. D squared whole. D square is x square plus y square. If this d square is less than or equal to 1, the point lies inside the circle. Therefore, we increment m by 1. M is increment. So this person we increment m by 1. If this condition is satisfied, the point lies inside the circle, we increment m by 1. Otherwise, we do nothing. Sigi condition is satisfied, say increment satisfied, do nothing. Yaraba. Smile. So this part, this 1, 2, 3, 4, these 4 lines are repeated how many times? N number of times. If n is 1000, it means these 4 lines are repeated 1000 times. How do you know? We are generating 1000 values of x and 1000 values of y. That means we are generating 1000 points. 1000 points in the first quadrant, and out of those 1000 points, if some points satisfy this condition, then those points lie inside this circle. Aduna m gi values increase torani. Adudagi if those points do not satisfy the condition, then m gi values increase toroi. Yarba. Okay. Adugadi ay kasagi sigi zil lore aduna after the end of this for loop, sigi for loop se end torbo matungda what do I have? M, this variable m contains the total number of points which lie inside the circle in the first quadrant. That is m. And what is n? N is the number of times the random points are generated. N is the total number of times the random points are generated. As I said, 1000 random points are generated. And all of those 1000 random points lie inside the square. And 1000 random points generate tawi haigre. Adudagi khara amari circle di manung tani haigre. Adubu 1000 random point generate toribo kuding makti square dugi manung taganeba. Why? Because the square z, it has side of length 1. So all those points which are generated, all those values of x, it would lie between 0 and 1, that is between this point and this point. Similarly, all those values of y which are generated lies between this point and this point. So all those points which are generated lie inside this square. Square because whatever number we are generating, that number lies between 0 and 1. Square. So number of points inside the square points, that is equal to the number of iterations in our particular program, in this program. So number of points inside the circle divided by number of points inside the square. Number of points inside the circle divided by number of points generated in this way. Generated to all these points generated, they lie in the square. Then you multiply the result by 4, that will give you an estimate of pi. So we multiply the number by 4 and multiply tore. This gives us an estimate of pi. Pi estimate on pirani, then we print that pi. So let me run this program, and we so enter the number of iterations. How many iterations do we want? Let us start with a small iteration. Say for example 10. Then enter tore, you press enter. We get a number 3.2. This is an estimate of pi. Let us increase the number of iterations. Increase the number of iterations to 100. Enter. Still we get 3.2. Manare say by chance niko. Manani have like. Let us run it again, and let us iterate it for 1000. 1000 number of times. Enter. Now I get a better answer, 3.148. So if you increase the number of iterations, so let us run it for 10,000. 1, 2, 3, 4. I number of iterations I expect to get better results. But I expect to get better results. So 3.1416 3.124. This is a reasonable estimate. This is a reasonable estimate, but not very good estimate. Then how do we increase the efficiency, or how do we make the result more accurate? In randomized and simulation algorithms like the Monte Carlo, the more the number of iterations, the more accurate the result is. When I increase the number of iterations from 10 to 1000, it becomes more accurate. Thus, the title is estimating the value of pi and not calculating the value of pi. Pi value calculate the estimate we can increase the accuracy further. Kamaina, the accuracy can be further increased by repeating the measurement many times, keeping the number of iterations fixed, and then taking their mean value. So I repeat, we can increase the accuracy further by repeating the measurement many times, keeping the number of iterations fixed, and taking their mean value. I will and say point 1000 generate I generate 1000 points which lie inside this square. Then from this I estimate the value of pi. I get 3.1 something. That is one measurement. Then I repeat the measurement. Another 1000 point generate inside this square. Then I estimate the value of pi again. Estimate pi value tarani. Sumaina 1000 points is generate pi value estimate so I say you repeat the measurement. You repeat the measurement many times. Repeat the row. Repeat the row measurement to many times. Repeat the row and then you take their arithmetic mean. Mean low. So I can hojik program the e hibdi kaino. I can hojik program the hibdi 1000 iteration taraga only one measurement katang low never. So man hojik kaino hojik measurement low process so you repeat that number of times and then you take the average. So let us look at another program. So this first program is estimating the value of pi by a single measurement. Now the second program is estimating the value of pi by repeated measurements. Pi value estimate now this measurement is repeated, and this is repeated for how many times? This is repeated for j in range 1000. This is repeated for 1000 times. So this measurement is repeated for 1000 times. 1000 times repeat let us repeat this measurement for 1000 times and let us see whether we get a more accurate answer. Today import random n equal to number of iterations. Pi have a empty list create empty list create because for a single measurement one variable is sufficient, but for many measurements of pi pi value I want to take them as the elements of a list. A single variable I list create and this 1000 measurements I want to make each of this 1000 measurements elements of pi. So ultimately this pi will be a list containing 1000 values. Already for j in range 1000 m equal to 0 initialize so m equal to 0. From here we start the program. From here part for m equal to 0 part whatever m equal to 0 initialize for I in range iteration character iterations n number of times input pivot random number x generate random number y generate then we check whether that point lies inside the circle target we increase the value of m by 1. Then after that what do we do? This temp, let us call it temp pi. This temp pi, let us call it temp pi. Okay. So this step calculates the value of pi, estimates the value of pi. Pi is 4.4 times m by n. So for the first loop this will give us the first value of pi. Already capital pi list append pi value whatever value we obtain for pi. Now you make it an element of the list. Elements the so after the first loop temp pi is the pi value after the second loop j second loop j first loop pi append temp pi is na now for j equal to 2 second loop pi append temp pi so at the end of Second, look for j. I'll have two values of pi here. These values may be the same or may be different. In general, they will be different. Aduna j is na 1000 loop matamda. I will generate 1000 values of temp pi, and all of these values will be appended in the list. The list so at the end of this program, this pi this pi will contain how many values of pi? 1000 estimates of pi. 1000 values of pi average. Now this is sum pi divided by length of pi. Sum pi sum pi list. Pi list. This list contains 1000 estimates of pi. So pi estimate divide by the length. Total number of elements 1000. So pi value 1000 again. This means this step simply means you calculate the average value of all those estimates of pi, or you calculate the average value of all those measurements of pi. Average value answer do capital P, capital I, variables then you print that variable pi. So this should give us the a more accurate value of pi. So let us see. Say that I said 10,000 times run to say 1000 times only run to single measurement. So single measurement, let us run the iteration for 1000 times. Let me run it for 1000 times. 1000. It gives an answer 3.076. Now, repeated measurements for the same number of iterations. That is for 1000 iterations. 1000 iterations. 1000. Let me enter. 3.142. 3.076 ka 3.142 ka. When you compare, you find that this is more accurate. So 1000 iterations taroga pi value je amutang measure to baneba. Sigisna 1000 iterations the pi value measure to bodo. Adugi measurement to hanjan to how many times correct to 1000 times to aduga amukari to magi average value loba. So accuracy the accuracy can be further increased by repeating the measurement many times, keeping the number of iterations fixed and taking their mean value instead of measuring the value only once. When we measure the value only once for 1000 iterations, we get the answer 3.076. But when we estimate, we perform the measurement for 1000 times, we get a better estimate, that is 3.142. It contains 1000 estimates of pi. So let us print pi. List print. Let us print this list. We should get a list which contains 1000 measurements of pi. A print is not defined. Sorry, capital P. It should be small p. See, these are 1000 estimates of pi. 3.136, 3.136, 3.156, 3.152, 3.22, 3.272. See, 1000 times measurement measurement average low, and that gives us more accurate answer. So that's all for today. Let me stop the recording here.